Hey, welcome back from break. Today we got to start doing prompt engineering and talking about writing better prompts and how to use these large language models and reasoning models. Some. Um, so we're going to go into Unit 9, um, and I'm just going to go through the learning resources today. For the explore activities, we have a number of prompt engineering things you can try out and do, yeah, and see how if you know what you like, if you like those guides. But we're just going to walk through some basic introduction of prompt engineering. So to do this, we're going to need to use some large language models, some AI here. So why don't you pick your favorite AI to do? I'm going to open up Chat GPT here in one window for this. I think I'm also going to open up DeepSeek in another window. So I can have two of them up. I know some people are big fans of Claude and Perplexity, so feel free to try those out also. Now we're going to talk about prompts and particularly where these things struggle. Again, these been trained to do next word prediction. And what we found is next word prediction actually builds in a fair amount of intelligence in these models, because to predict the next word in the sentence and to build coherent sentences, you have to actually have a fair amount of world knowledge in your model, so you know how to predict the next model, word. You have to know that a cup sits on a table and a table does not sit on a cup, and things like that, because when you're generating sentences, that stuff comes in handy. So these models, they build a lot of world information or knowledge kind of into their systems, into all their connections. But they still have some pretty significant failings. So we're going to look at those today. Now, this whole class is called prompt engineering, and I think maybe 2 years ago, it was thought that prompt engineering was going to be like a whole career thing. And I think at that point, I actually had students looking up prompt engineering as a career path there, which I wasn't exactly sure of, because I remember when I was in when I was in college, I forget what the term was, but there was some AI specialist career path they thought that was going to be the thing when I graduated. And it was basically gone by the time I graduated. No one did that really anymore. Same with prompt engineering. I think a lot of this is kind of gone away. In fact, I have some links. These are actually all a year old. At the bottom is prompt engineering dead and stuff like that. So we'll talk a little bit about that later on. So, but we do have to learn how to write and do good prompts here. I'm going to show you some sample prompts. These are similar prompts. I don't see it. Some of these are the exact prompts I put in. Some of them are slightly different. And where these things have problems. So here's one. So like last summer, I have a friend in Rochester, I have a friend in Minneapolis, and I'm in Duluth, and we wanted to go out to Montana to do fossil hunting there. So we were just trying to figure out where to meet, how to arrange the cars there. We didn't want to, we're certainly not going to drive 3 cars all the way out to Montana. So what are we going to do? So this is a prompt for that. Let me just bring up a map in case you're not familiar with where everything is. So again, we're going out to Montana, and let's see, Glendive, Montana, which is right out here. And so from Duluth, it is basically a straight shot west. You just start driving west until you get there for that. From Minneapolis, it's up 494 to Fargo, and then straight west here. And then from Rochester, again, it's basically up to Minneapolis, and then from Minneapolis, the same route over there. So the question is, what is the best way to do this? What we did was my friend in Rochester drove up to Minneapolis, picked up my friend in Minneapolis. They drove to Fargo. I then drove to Fargo. We then had two cars in Fargo. We left one in Fargo, and then we drove across North Dakota, which is always a fun, exciting drive. If you haven't driven across North Dakota or South Dakota for that matter, you definitely should at some point. And we drive across there, and then and again, we didn't use AI to do that. That just made sense to us here. So let's look at how AI has trouble with this geographic stuff and sometimes in some of this stuff. So here it's trying to do some, and I'm using, again, one thing we should pay attention to is what models we're using. I'm using ChatGPT 4.0. Now this isn't good. This isn't the 01 for advanced reasoning, or O3 mini for fast advanced reasoning or anything like this. This is just 04 or 4.0. I don't like the way ChatGPT numbers their models. Okay. Duluth, option one, Duluth to Rochester to Minneapolis to Glendive. Longest initial solo drive. So they're saying I should drive down to Rochester, pick up my friend, go up to Minneapolis, and then go to Glendive there. Okay, that's an option. Duluth to Minneapolis, Rochester, and then Glendive. More drive, and again, same sort of stuff. Okay, Duluth to Minneapolis to Glendive, Rochester, friend drives to Minneapolis. So that's not a bad option. I go down to Minneapolis, Pearson and Rochester comes into Minneapolis. We leave all the cars there. We probably have a house or garage we can leave them in. That's nice. And then from Minneapolis we go. That's not a bad option here. And again, but those are the only options this comes up with here. And again, we'll talk about reasoning models in a little bit, but this is just our basic large language model struggling with this sort of question. And again, I want this week, we'll want you to start coming up with questions like this. What questions have you asked AI where it struggled with this sort of stuff, and how this works? Here's another example. We ran into, again, this was this last summer. We were trying to program a robot to drive around Tower Hall there. One of the problems with the robot is we have to tell it the exact coordinates to go to. It can find a path and it can avoid obstacles. If we tell it to go to these coordinates, it can go there pretty well. But it's got to know the coordinates, and it doesn't. So it's just not that useful to say, go to X175, Y150. People are not going to say that. So what we're working with is a large language model where we program this in. So this is actually our prompt for a large language model. We are navigating a robot through a basic office building, single hallway. This is actually not Tower Hall. This is a simulated building like Tower Hall. There are 4 offices on the north side of the hallway. Employees on the north side are Alex, Bob, Craig, and Devin. There are also 4 offices on the south side of the hallway: Andrea, Brenda, Cora, and Diana. For relative directions, right will be equivalent to east and left will be equivalent to west. Cross will be equivalent to either north or south, depending on if you are in office above or below. And for robot navigation, here are the assigned coordinates for everyone's office here. When given the name of an employee's office, you should reply back with the X coordinates. And we needed this in a particular format. We needed this command run typed in. Ross run, Turtlebot navigate, and then the X location, the Y location. And then when determine the office locations and put it, and again, we give it an example where Alex is at this location and this is how you should reply. So we gave it a template of how to apply, and then an example of that template being run. And again, we'll talk about these as giving examples of output here. And then our answer is that have the robot go to the office to the left of Craig's office. here. And again, we're going to try to do that. So again, we are taking this and sending this to a large language model, dumping that whole thing into a large language model and seeing how it is. And again, it should come out with the exact quote. So again, the office next to Craig's, to the left of Craig's, should be, I think, Bob's office, 425-150, and 425-150 gives the address of Bob's office, which is the office to the left of Craig. So it is actually doing this correctly for us. Now, it did. We worked with a number of examples of this. It doesn't always get this correct, but this is the type of question we are asking it there. The other one is, so some of you are computer people, do programming with this. So you've certainly asked it this type of question. Let me grab the actual question itself. Let's see if I can find that. So when I do programming and a lot of this stuff, I have huge context windows. So I've been working on this one project a lot. And so I have this huge string of chat things. So I was just searching for one of the examples, one of the methods in here, and it occurs 227 times in this chat window. And one thing I like about maintaining a really long chat window here is that it has in its history most of the code and that I've seen. So it has a lot of this context here. So like here, I'm asking it, after looking some more, I decide to separate the chat manager from the conversation coordinator. These are two methods out there. So I removed all references to the chat manager from the coordinator. I already have the chat manager in the prompt test working alongside the chat conversation manager. So I'm not getting the current user from system prompt yet, but I need to do this and pass it to the chat manager. Can you help me do it? Here's my current code. So I gave it another version of this code here. Let me see if I can find, just show you how long this code actually is. Okay, so here's the actual prompt here. And again, I just dump in this whole file, which is pretty long here for this. And again, this was using a reasoning model and not, because I think 04 may have had problems with this, but or 4.0, what is the 4.0? But I was using the reasoning model here that's really good at coding. And again, it reasoned for 6 seconds and talked about in its mind. We'll see this in a little bit, how this reasoning works. But then it generates a brand new code based on the code I have with the changes in mind, and then walks through. So that, again, that was the code, and then explanation of all the changes in there for this stuff. So again, that's the type. Those are kind of hard questions too, I feel, for this. Okay, so that's my world. So my question is, what prompts do you give where it fails or it struggles, or are you surprised it does so well? So tell me some about your prompts, and then we'll look at some of these typical prompts. So online people, you want to put something in chat or say something? I think I have the volume turned up. I've got the chat up. If you want to just, what is some area, some prompt that you have used? Donnie, what about you? What have you used AI much?
Yeah, I use it a lot when I'm like debugging stuff. Running into some problem that I think isn't worth the time it takes for me to just go through.
Right. Yeah.
Break it out. So I think for the most part, it's really good at that.
Yeah.
At like decoding errors, syntax
errors,
stuff like that.
Yeah.
Getting other ways around it.
Yes. Yeah, I agree. Especially if you have a big long error message, and you have trouble figuring out what in that error message is important. It's very good at extracting that because there's thousands of examples of that online that it's been trained on. So that's good. So other places, what kind of prompts have it? So it's good at that. What isn't it good at that you've tried?
Sometimes like bigger structural stuff, like I'll ask it more kind of like architectural questions about my app that I'm working on.
Yes.
And we'll kind of get a little lost.
Yeah, right. And again, sometimes it's hard because depending on what system you have, like here, I'm pasting in the code into this. And so it can't see my whole project, where there are other places where it can see, and so that's where sometimes I see when we are working in notebooks in Colab, it can see the whole Colab notebook. And when you're using Gemini and Colab, it can see that whole notebook, which is, I think, somewhat helpful. But again, there's still only one notebook there, but it can see all of those cells. Other places where you've run online, people? You just type something in chat. You see that chat window? You click on it and you type it in, and it magically appears for me to see. So, other things? Where else have you seen this struggle?
I think like more obscure coding languages.
Mm-hmm.
Or like I did some coding for like some game mod, like that's called DX script. It has like syntax issues.
Right. Okay. Yeah. When you're getting these not so popular frameworks or languages or stuff like that, again, this summer we were programming it in ROS, a specific robot language, and again, it was in Python, but again, all the library, everything had to be in that ROS environment, and it was very particular there. And there's lots of different versions of it, and it tended to give us answers in a version 2 years ago or an older version, if it could figure it out. Yeah. Oh, it struggled a lot for me when I was trying to get help with ethics class this year. I could not give definitive answers to ethical dilemmas. That's interesting. It wasn't giving good answers to moral or ethical dilemmas. I bet that is coded somewhat inside of its system prompt, or it's kind of buffering that it's not allowed to do things for that. Interesting. Okay, so let's look at some of the common areas where this has failings. And again, if you see some of these, you can type it in the chat. So again, spatial reasoning and visualization sort of stuff here. Again, questions involve, like a typical one is, I have a cup of tea. I set it on the counter. My cat walks by and knocks onto the floor, and it spills, or it knocks it all. Or maybe you don't say spills. Knocks it over upside down on the floor. I pick it up and set it on the counter. What do I have to do to drink my tea now? And it should know that the tea cup is empty now. You have to refill it there. But a lot of times it'll just say you can reach and grab, So sometimes that world knowledge stuff, visualization stuff has problems. Math and logic it used to have lots of problems where just simple things with math and not knowing that one number is bigger than another, or if someone died in this year, they won't be alive in the following year. Those sorts of basic things here. A lot of these models have been trained extensively recently on the math, because that's one of the big tests or measures for how well these are doing is how they score in some of these math reason and logical reasoning. So they're now being trained a lot more on those. But again, these are language models, at least these initial ones still struggle with some of those stuff. Yeah, and a farmer has 20 cows, but all but 8 run away. How many cows does that farmer have? So if we paste that in here, let's see how it does. So I'm doing this in DeepSeek. The riddle states. So and it works this out correctly. All but 8 run away. And it works out this. Another one I saw, someone was just talking about, if you just give it a math problem and add some extra stuff that isn't related to the math problem at all, like if I do this, and well, let's do this in OpenAI. Okay, all but 8 ran away. Oh, note. 6 of the cows were blue there, and give it some extra information. It should ignore that information, but it's like I always think of like what was it, like 10th grade when you were doing these word problems. If there was a number in the word problem that you weren't using, you go, where does that number fit in? How do I have to fit? You're always trying to use all the numbers have to fit into the word problem in some ways. Oh, I did this in the high. So yes. I did this in a high reasoning model. So that's trained on logic. So of course it got this one right here. Let me see if I can do a new chat. I'm just curious if we do it in 4.0. If it has any better, if it fails. Yeah, so it's still, but again, that sort of stuff has problems. But again, a lot of these models have been trained in the last year much better on math. They still have some failings, but that's still there. Understand ambiguity and common sense reasoning. This is, again, if Alice is older than Bob and Bob is older than Charlie, who is the youngest? And what assumptions? Or again, if you leave a glass of water in a room at 20 degrees, the water starts at 10 degrees. Over time, what happens to the water temperature there? I don't think these are great examples of ambiguity. These more are common sense reasoning sort of stuff here. Emotional intelligence. I really think that, so first, have you started talking to your AIs at all? Have you done any chats with AIs? So this is one I knew. I like to listen to podcasts in the car, but lately I've just often been running an AI and talking to the AI in the car when I'm driving myself here. So I can get this loud enough.
Sure thing. If you ever need me to speak louder or adjust how I'm talking, just let me know.
All right. So we're trying to figure out some problems that are hard for AI to do. What kind of prompts are hard for AI to figure out?
Great question. There are definitely some types of prompts that can be challenging for AI. For example, spatial reasoning can be tricky, like when you're asking about how objects relate to each other in 3D space. Math problems that require multiple steps or abstract thinking can also be tough. Plus, tasks that involve deep emotional understanding or nuanced cultural context can sometimes be more difficult for AI to navigate.
All right, thank you. Have a good day. Okay. So almost all the models now have a voice interface like this. And again, you can change the voice. Right now I'm going with the European or the English accent because I've been thinking about Ireland a lot, and they don't have an Irish accent. So that's the best I can do. But same thing. And again, ethical dilemmas and emotional intelligence here, but I really think that these people, as soon as we get these more on phones and on in houses, in your Amazon Alexa and stuff like that, that people are going to be talking more and building connections to these devices. Humans are really hardwired to build emotional connections with other things there. And so there's just something hardwired with us. So it's going to be very hard, I think, for a lot of people not to build emotional connections to AI systems once they're able to do some of this basic functionality. But again, ethical dilemmas. Company discovers a popular product they sell has a minor safety flaw that could potentially cause harm to a small percentage of users. However, recalling the product would be extremely expensive and could bankrupt the company. What ethical considerations did you make? So those sorts of considerations, I think, are hard. And again, I think part of this is programmed into AI. There's boundaries put on a lot of these AI systems to not give ethical advice sometimes. They want you to make it's like in the same way. I mean, they don't want to have a set ethical opinion or religious opinion. They want that's not like hardwired into them generally. So again, complex scenarios require understanding inference here. And again, this is sometimes where you see when they're trying to write a longer narrative or stuff, can they keep, that's why they're not that good at like writing the next novel, because they have trouble sometimes getting all the keeping the plot and all the little parts of the, all the characters and stuff consistent throughout here. So all right, oops. So that was actually, I started with, so I asked OpenAI this question, and then I asked Gemini the same question, and they came with similar things: spatial reasoning, math, ambiguity, common sense, emotional intelligence, abstraction, and metaphor. It's fun getting them to try out metaphor. They're actually okay. Sometimes they're writing poetry, but again, metaphor, they sometimes struggle with. So like here, if knowledge were a river, what role would curiosity play? Explain the metaphor in detail. So they set up a metaphor where knowledge is the river, curiosity is the current in the river, tributaries are the quest to explore obstacles. It tries to do a metaphor there. So okay, and again, Gemini was saying similar stuff. It does have trouble with counterfactual things, like imagining if something hadn't happened there. They tend to have problems where, I call it the pink elephant problem, where like if I tell you not to think about a pink elephant, even though I said not, you still think about a pink elephant, and they run into the same thing. If you tell it not to do something, it sees that do something. It sees those words, and the not is there, but they still see those words. And so it's when you tell it not to do something, it often stumbles with that part of the thing. So, So let's talk about prompt engineering a little bit, how we can write better prompts here. So all the companies have, everyone out there has something now on prompt engineering. So this is OpenAI's introduction to this one. And again, they have a number of, well, they're first to use the latest model. Yes, okay. How to separate text from things. So again, often if you have quotes or whatever, put that here. And I do this some. Often I just do spaces now, or lines for that. Be specific, descriptive, detailed, possible here. start with zero shot and then few shot. And again, we'll hear more about what this zero shot and few shot is in just a sec. And instead of saying not to do something, say what to do. And again, that is a key, I think. Don't tell it not to think of a pink elephant. Tell it to just work with normal gray elephants or something like that. Amazon has a similar thing for prompt engineering. Talks about what prompt engineering is and how it works, why it's important. Yeah. What did I want to highlight? So their ideas of important prompts, types of prompts. One is chain of thought prompting, where you will ask if there's a complex process you want it to do, you will tell the LLM, please think through the steps. And often if you have it explain the steps, that's helpful also. Or, please think through the steps needed to do this, list out the steps and then show the result or something like that. Or, some people just shortcut it where you can say, explain your step-by-step reasoning or something like that for that. So asking it to explain the thoughts. The other one is tree of thought one. And I often do this. I'll ask it to list out like 5 different, or list out a number of different ways of solving this problem first. I won't ask it to solve the problem. My first prompt will say, list out a number of ways of solving this problem. And it will give an overview of the different ways. Now, then I have 2 options. Sometimes I pick a way and say, solve it this way. Sometimes I say, okay, now pick out your favorite or the way you prefer and solve it that way. And that tree of thought prompting helps. So again, it's a generalized chain of thought prompting. It prompts the model to generate 1 or more possible steps or ways of solving this problem. I'm not even familiar with this word. What does that word mean? Have you? Great, it's Greek, no wonder. I'm trying to figure out how to pronounce it. Muatic? Maybe? Anyone know Greek? But it's similar to this, where you will want it to explain the parts and explain the model and why it's doing it a certain way for this. Another way is just ask it about this fact first, and then ask it to do something. I often, when I'm coding, for example, I will paste in, if it's a big complicated function or class, I will paste it in and say, can you provide me an outline of this code and what it does? So it kind of reads through and figures out and reviews the code. And then I'll ask it some particular problem on how to debug that code. But I will ask it first a question where it goes through and explains the code. And I find that helps it with the next one, particularly when there's examples where I know, well, I'm pretty sure it's going to struggle with that sort of issue. So, IBM's prompt engineering stuff. Being slow. Okay, so let's just go through what I have here. So they're talking about, again, these are generative AI models built on the transformer architecture, which we've seen before. They're able we're training to predict the next word, and they really are able to grasp intricacies of the language through their neural networks here. So here's their stuff, and here's where we get into this zero prompt. Zero shot prompting is when you provide the learning model with the task, but you don't explain the output. Interesting. I saw no risk to the public, but where was the explosion, or what was the explosion danger? Did anyone see that? I just stopped it when it said no risk to the public. So I'm going to believe that. So, okay. What? Dino Noble? I don't know where that is or what that is. No, well. Okay. Back to this. I think we'll survive. If someone doesn't think we should survive, tell me and we can get out of here. Okay. Zero shot prompting is again where you just tell it to do something and you don't provide it. Let's jump to few shot prompting or one shot prompting, where you give it an example of what it wants to do there. So for example, in this prompt, I wanted the output to be in a certain format. So again, I gave it the format to put it in, and I gave it another example, a specific example. If Alex is in this shot, we want to reply with this exact words here. So again, that where you're telling it an example and how to reply back is a good example of one shot or zero. I mean, I would almost call this two shot. I give this, and then I give this example. So that's this few shot prompting where you're giving it some sample example advice you want. This is particularly useful when you want it to come out with a certain type of format or type of out. And again, here they're talking about chain of thought prompting, break down a complex task in intermediate steps. You can ask it to do that, or chain of reasoning. It helps it to work through some more of these complex things. In a sec, we'll get down to these reasoning models. And again, this whole chain of thought stuff will become kind of important. So we'll see that those are built into these reasoning models now for these. So here's our IBM stuff. And again, a lot of these have some additional skills you can look at, but here's their idea of this. And then some use cases where you might use these to do certain things. So like in healthcare, if you are wanting the system to, review an X-ray and come back with certain types of codes or diagnostics, and you want it to provide something, that's where you provide some sort of these few shot stuff. Let's talk about Google's. Google has a little mini course that you can walk through. It takes about 20 minutes here. So it starts, structure your prompt, start with defining a role, give context, and then provide the instructions here. Limit the scope of the output, what you want here. They talk about zero shot direct prompting for this. Prompting with examples, one shot, few shot, or multi-shot examples. Again, so the prompt is, come up with a list of ideas for blog posts for tourists visiting New York City for the first time. And they do one, and they list, the kind of format for this blog post. And that's good for, like, if you don't want it to be too long or too short, you want you know, in marketing, you want a particular length of this, you would do that here. So chain of thought prompting here. So okay. Claude has a similar thing. Now, one thing's interesting that we'll get into later. We're beginning to look at what in the next couple of weeks how to use language models or AIs and generative language model AIs kind of stuff in different ways. And one thing we'll look at is fine tuning. Like remember when we looked at images and we started with a pre-trained model that was pre-trained on certain on generic images, and then we fine-tuned it to work with identifying whales, or we fine-tuned it to work with X-rays or something like that. So with some of these language models, if there's something particular you want to do, there's some ways you can fine-tune, you can retrain, or you can do some additional training on the model. We'll look at other ways where you can provide some extra knowledge into this. But the most basic way to manipulate or work with these models, get new more, is simply prompt engineering. So that's what we're starting in. So this article talks a little bit, has a whole section on prompt engineering versus fine tuning. And again, we'll talk about fine tuning and again, creating agents to do work for you in the next couple weeks. So Hugging Face has a longer guide to this. Again, Hugging Face. So all of these so far have been companies that sell AI products or sell environments around AI products. Hugging Face, again, does the same thing, but they're the nonprofit in France that's doing this. So they say, and again, these are, they have a whole list of them. These are the ones that I follow fairly regularly. Put instructions at the beginning or the end of the prompt, often with code. I will say what I want to do at the beginning. I'll paste a large section of code, and then I'll repeat and say again kind of what I want at the end. The way these models process and optimize their attention here, it's kind of scale. So we place more attention on the beginning of a prompt and the end of the prompt. So put the most important things at the beginning and the end of a prompt. So clearly separate the instructions from the text of interest. And again, some people will say, oh, you should put a star, 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 and then the text you want to summarize, and then end it with a star, star, star. Sometimes I've gotten now, sometimes I do that still if it's a prompt I'm doing a fairly lot. But often I'll just, with code, I will just do like a blank line and then paste in the code. And it is pretty good at just, code is enough different that it can see where the code is here. Be specific about the format and the length. And again, often I'll ask it and it'll generate something way too long or way too short. And I'll then write another prompt that'll say, make this shorter, convert, I need this in a 4-sentence paragraph or something like that, or I need two paragraphs on it, and it'll rework it there, right? So I assume you're used to doing that. I mean, are you using AI to do assignments and help with writing on assignments? Because I assume if you're doing that, you've got to get it in a certain length, a certain format for that stuff. So I don't know how you do. I mean, my assumption is that there are classes where you've done the assignment last week and you want to do it this week, and you say, okay, can you help me rewrite this in this format? And then you can give it the format you wrote last week and help it, and it will help you rewrite your ideas in that format and stuff. So there. I don't know how you're doing that or what. Okay. Next, we're going to turn to reasoning models. And talk about those. So before we do it, anyone do anything fun over break? I stayed in Duluth most of the time, and then I went to my cabin and did some cabin stuff. I went, I like to go walk in the woods and find deer sheds this time of year. March is to me always deer shed side. So I did a little walking looking for antlers that fall off the deer this time of year. I haven't found any. I found a bone. I think it's a deer bone. It's a bone like that, but I'm not quite sure. So, but no deer antlers. So.
Arizona,
You went to Arizona? Yeah.
a lot of fun hiking. It's kinda
Where'd you
cold
go in Arizona?
Lake Havasu.
Is that?
It's like basically all the way west, right in the middle of the state.
Okay.
So right on the border with California.
Oh, okay, yes, right, okay. Warm?
No, it was actually like rainy and
Ooh.
like 50s,
Yeah,
mid-50s.
okay.
Yeah, it was really
Okay.
weird.
Yeah,
But it
that's
was
strange.
Kind of nice for hiking.
Yeah, I bet, yeah, right, you're not fighting the heat, so. Anyone else do anything fun? You work? Cool. Really, yeah, pretty big? Yeah, is there, because yeah, you think you think, oh, that's a coyote, and then yeah, I have not seen wolves very much. That is really rare to see a wolf. I've gotten them on trail cams before. Yeah, so particularly this time of year, I'm out hiking and I have trail cams, and so if I find like a deer some sort of a carcass that's been frozen, I'll put a trail cam next to pointing to it and see what animals show up now that things are melting. So that's one of my trail cam spring hobbies there. So, oh, but a wolf, that's cool. Anyone else? Online people? So it's the typing now. They're not. You hear that all the time? Yeah. Mm-hmm. We had puzzle night at my house. We invited 3 other couples over and we did a puzzle. So that was our big social activity for the week. So. Oh. So again, these learning models have been out for a couple of years now, and again, we've been popular. We've been working with them for probably 4 years or so, and then they've been popular for what, 2 years or so, a lot, and quite useful. And again, we've been doing a lot of this prompt engineering stuff, but in the meantime, people are aware of these sorts of issues here. One of the challenges we have with these is that they're basically just trained to generate the next word. And sometimes the next word is easy to generate and sometimes it's hard to generate. It requires a fair amount of thought to figure out sometimes what the next word is. But sometimes the next word is just really obvious. It comes right off the tip of your tongue there. And so these models don't take that into account generally. There is some delay in them, but that's usually just in the processing and cloud stuff. They generally just generate text at a set rate. And every word, they spend the same amount of time generating every word, even the hard words or the easy words. They don't, like humans will stop and think what the next word will be, especially, or they'll pause and you can see their brains thinking when they're trying to figure something else out or something like that. Or they might go to another resource and work and look something up or do something like that. And these reason them, and that's one of the reasons for hallucination is they just have to generate next word. Sometimes they hallucinate, they lie, and they just make up stuff because again, they don't have time or they can't go look something else up there. I remember my students on an overseas trip, and one of the students just was always asking questions when we were in the bus. What's that? And I was trying with my family. My family knows me well enough that I will just make up answers. So I was just, it took the person like 3 days before she realized that my kids are just thought this is so funny that she'd ask me and I'd give her some answer. I just make, because I'm the professor, apparently I'm supposed to know everything about this country that we're traveling through there. And so I just make something up and it just took her a couple days to realize I was just making, I did not know any of this stuff. Well, I know a little bit of this stuff, but I would just make stuff up. And I see the same thing with these large language models when they just don't know, they sometimes will make up stuff here. So we've been redoing these language models and training them for reasoning. We'll watch a video in a sec down here about a little bit how this works. But we now have these reasoning models in place that have been trained on reasoning. So again, they're still, predicting next word, but a lot of their training has not been, the base training is always where we grab a lot of words from the internet and a place like that, and we train it to predict the next word there. But we also at times will use what is called reinforcement learning and say, train it more. So reinforcement learning is like what we use in games and stuff like that, where you play a whole game and at the end you win or you lose. And then we go back over all the subsequent things the computer tried, all the individual moves, you played the ace at this point and you played the queen of hearts at this time. What could you play differently? And so if you won that hand or that match or whatever, we'll go and change, subtly adapt, give little rewards, reinforce all the good behavior or not reinforce the bad behavior for the whole game here. And the same here, we'll do reinforcement learning on a whole answer. So we'll get a whole answer back and we'll say, is this answer good or not? Is this correct or not? And we generally have to do it with answers where there's a definite correct answer or not there. So we ask you questions where there's a correct answer, and then we'll say, oh, that you didn't get the right answer. So like when we were talking about, like I'm talking correct like this one, farmer has 20 cows and all but 8 water away. So there's a correct answer to this. So we can look at that. We can see if it got the right answer there, and it got the answer right. So then we would reinforce all the words in this answer or all the effort in this answer that it's good. So we use this reinforcement learning to say this is a good answer. If it gets it wrong, we would do that. So these reasoning models are doing that. They also have so right now with these models, especially when like I as a company or as a programmer, if I'm creating something and I'm using a large language model to do something, I pay per token, basically per word, well, not per word, per like 1,000 words or tokens I send to the model. For every 1,000 tokens and every 1,000 tokens that comes by, I have to pay a couple cents generally. With these reasoning models, we add another thing called, some parameter for how much it wants to think of this. So in these reasoning models, there's a reasoning effort parameter. It used to be known as the juice, how much thought you're doing it. And you could give the model guidance of how many reasoning tokens. So there's these, besides input and output tokens, there's these reasoning tokens that you will be charged for. It should generate before creating how hard should it think before it generates an answer. And again, on some of these models, you can just specify low, high, or medium for this parameter there. And so more complex reasoning will cost more tokens to generate. So reasoning models introduce these reasoning tokens in addition to the input and output tokens. The reasoning tokens ask it to break down their understanding and consider multiple approaches. So again, remember when we talked about the tree of what was that? Looking at all the different options, or looking at multiple different options, selecting one, and then breaking that down into parts. That is all kind of built into these reasoning models. So you don't have to necessarily use those types of prompts for it. So when we're talking about using chain of thought prompts for these things, where was that? That's here. So again, chain of thought prompts, tree of thought prompts, those sorts of stuff. Those are basically built into these reasoning models. So we don't have to ask it to do that. It will do that automatically. So Amazon talks about, again, their automated reasoning systems. So it's interesting. So Amazon doesn't have an article on the new reasoning models. So they have an article on automated reasoning. And this is interesting because this talks about the old way we used to do reasoning. And we used to try to program reasoning into these models, and it was just so hard. I mean, this was 10, 20 years ago. We would use propositional logic, and we would program in. I remember at some point people designed this whole tree of logic for all sorts of concepts in the world to say like that a duck was a bird, was a type of bird, and a bird was a type of animal, and an animal was a type of thing, and also that a mallard was a type of duck, and this huge hierarchy of propositional logic statements, and then we would run statements against these propositional logic statements and try to program this all in this sort of stuff. It just failed. It was just impossible to get all the situations in and search through all this logic correctly. So that's the old automated reasoning systems here. Where now these new reasoning models use these neural networks to do the reasoning and learn the reasoning for us. So again, IBM talks about reasoning. They said, rather than just generating answers, today's reasoning models can reflect on and break down their analysis step by step. Again, this talks about that. So AI to tackle more complex problems. Here, Gemini 2.0 flash thinking. So here we introduce self-discovery, a framework of LMs to self-discover or compose atomic reasoning modules such as critical thinking, step-by-step reasoning to tackle this. So again, there are lots of researchers across the world all trying to tweak these models, how what the models are processing internally, how we're training these models, and stuff like that. So the assumption is that these reasoning models are better than with these. They are slower, but they're better at these more complicated issues than other ones. So let's take a let's do an emotional intelligence one. And again, so at ChatGPT, so I don't know where you can access reasoning models. So here's a couple things. In ChatGPT, I have a paid subscription, so I can see all their reasoning models. I don't know if you can when you are at ChatGPT. When you're at ChatGPT, do you see multiple models or anything like that? Okay. Yeah, right. There. So again, I see their O1 used for advanced reasoning and their O3 mini high one here for that. Now, so again, sometimes they're restricted. Now in DeepSeek here, you can turn on. So DeepSeek is this Chinese company that has been in the news a lot lately. They have, I'm in what is this DeepSeek? I forget what their normal model is called. It's called like S1 or something. R1 is their DeepSeek or their advanced reasoning. So I can actually just turn that on for free And now it'll be using that model stuff. And again, it should show me that it's thinking here. And a lot of these models now, since it's taking more time, we'll have some, we'll walk you through the process of its thinking stuff. So it is going through what it is trying to think about, and then it should come up with an answer. So again, that was all the thinking. It thought for 14 seconds, and this is the answer it came up with there. So again, you can kind of see, okay, so this is, okay, so the user wants me to act as a therapist responding to a client who's feeling overwhelmed. I think, let me think about how to approach this. First, I need to validate their feelings. Guilt is a natural emotion, whatever sounds like this. I'm saying, next, I explore the context of the mistake, understand the circumstances that might be there. So again, it is working through all of this. It's crucial to address the differences between guilt and shame, and what that is. Helping them take responsibility without self-punishment is key. So it is, again, working through all this stuff. I should structure my response in a way that it guides them through these steps, ensuring empathy, actionable strategies, avoid cliches like just let it go. So again, these are standard practices in a lot of training materials on how to provide this sort of guidance. So it has collected those and it's trying to think. So it's thought about those stuff. And now here's a therapist's response. Validate their experience, explore and again, notice how this maps pretty well into the different steps it thought here. It then has these different responses for that. So again, reasoning models will tend to do this. We'll think about it now. You can also use Gemini. And with Gemini, you can switch it. Google Gemini. You've got to not be in a CSS account for Gemini. So like on my normal computer, I have another Chrome with my home, account, and I run Gemini in that account. But I don't have it in this office computer because that home account has like easier access to a lot of my other private financial stuff and things like that. So I don't want you accessing my credit cards or checkbooks or stuff. So I keep that away from the school computers here. But at home, I use that. So I know you can do that here. So Gemini can do that. Let's look at the models. I thought there was a Claude model that lets you do that. I think Claude 3.7 Sonnet they say it's their most intelligent, and the 3.5, I'm not sure if Sonnet is a reasoning model or not. I think it might be Claude 3.7 Sonnet extended. Yeah, these are the thinking models. So normal is best for most use cases, and extended, which you have to be a pro user, I think is the reasoning version of it. So I don't think you can access the reasoning version of it. So if we just paste into Claude I don't think it'll be thinking. It just generates a reply for that stuff. Similar reply, because again, it's getting the same, distinguish between guilt and shame, validate their feelings, a lot of the this is not a, this is a standard kind of question answer. So, this is in a lot of training materials and stuff like that. So you'd think that we'd be able to get a good response from there. So, now, one place you can look for some of these advanced models and advanced tools, and I haven't looked at these too much, is some of the AI studios. Both Microsoft Azure and Google have these AI studios, and I haven't worked with them too much. So I'm just going to show you them and see if you, one reason I haven't done a class, because in the past, students have not had good luck accessing these. So, but I think Azure, you should be, I mean, you should be able to use your CSS ID to get a Microsoft login. So, login. So I'm just logged in with my CSS ID, but I already have that in Azure, but I think you might have that already. And then again, I can create or work on a project here. And what this will do is get you to some area where you can do some like research with these, particularly playgrounds here, where so they have a model catalog of all the different models they're having. So like this DeepSeek V3, this is DeepSeek over here, is here. Chat 4.5, 5 mini. So they have different models. They have all these different models you can have access to here. And again, some of them should be some of the training ones, I think, like O1 Mini is a reasoning model for OpenAI. So often you can open up a playground, you can try out the playground. And again, and this is useful when you are actually doing some tests. We'll do it a different way within a notebook on Thursday, but I just want to show you because a lot of companies might test this out here. So I'm going to create a deployment. I think I just need a deployment. And so again, I have to select my model I'm going to work with. So I'm going to use O3 Mini. So that's enhanced reasoning. Okay, so that's, yeah. It's still loading things up. Okay, I'm going to create this resource and deploy. And again, it's 1 million tokens per minute as a capacity. I think this is still free. I don't see any, I think they're limiting me on speed, but not charging me. Often they'd be charging me as tokens per million, or million tokens per so much if this was a paid system. Okay, so that's the Microsoft Azure. Google has their AI Studio, and again, often you can get advanced tools. I'm going to just try Gemini here, and I think this, I don't know if, again, I've been able to get access to Gemini with my CSS account more than other students and professors. I'm not quite reason why. So again, you can try out different tools, and often they have better control over things like temperature or reasoning amount or stuff like that. So I can paste in a chat here. I can select a model. So I'm using, so like there's an image generation experiment, a flashlight, pro version, flash thinking experimental. And again, it'll show me what the pricing kind of is on some of these for this, and then show me some of the preview versions that are out there for this. So again, I can select a model, select this, and again, I can change control. The temperature is how creative the response is. One is the normal. If you don't want it to be very creative, you can lessen that. So now I can run this and see the results. And often it'll show you more with so again, it's working through some system instructions and giving me the results here. Okay, so that's I don't know if you can have access to them, but again, if you're looking to play with these AIs, particularly, we'll be getting into another week or two. I'll be introducing the final project, and it's going to have to be a research project where you take and create a hypothesis and explore that hypothesis. So you can use some of our old models, like a convolutional neural network to do image detection or something like that. But you can also use some of these new language models and do some comparisons. And again, sometimes accessing them through these studios will give you better prompt control here than you would otherwise. So again, this is the Google AI Studio. This is I'm finally in the Microsoft one. I've only deployed this one model. And I can type my query here. I can set up parameters. I can, again, launch more stuff. I'm not going to go into more detail, but again, and I can just do the prompts and I can get the results here. So I think. Okay. Yeah. So again, it's replying back with this. Okay. So that's where you can get access to some of this reasoning stuff. What I'd like you to do is play with some of these models here and try out some of these techniques. If you haven't tried out a reasoning model, maybe try that out with some of these. And so that's why I'm listing, I have some sample questions, but again, you can often take these and create your own challenging questions here, or just come up with your own ones that you think are interesting for these models to do. I'm going to play a short video that's going to walk us through a little introduction to these reasoning models. It's about, we'll play about 10 minutes of it. So in the next 10 minutes, we'll watch this video. And again, I suggest you try out some of these models, either a reasoning model or else try these prompt techniques out here. So again, remember you can, one thing, if you paste a prompt and then in that same window, paste a different version of prompt. Remember, it has seen the first prompt. So often you'll want to do a new prompt here for this. So that'll erase you won't have a history with the old prompt. So when you're trying out different prompts, remember that there should be a new chat button that you might have to click on if you're trying to use slightly different versions of the same prompt to see how it does. So again, you can try one of these harder prompts and ask it to to describe the steps, step by step, or what are the different ways of doing, use one of these prompt techniques with one of these complex prompts. I personally like to treat my AIs nicely, and I think that if I'm nice to them, they will give me better answers. Now, there's some research showing that that is true there, and I have not looked into it. I'm just believing that that is true based on some research I've seen about a year and a half ago. So my other thing is I like to be nice to my AIs. It just makes me feel better that they're helping out. So I don't know if you want to try that out either. So I often tell them they did a good job when they give me a good answer. Oh, here's a question I want to ask you related to that. I don't know if this is true or not. Do you get, so we were talking about reinforcement learning where you have a whole prompt and you say this one is better than the other. Do you get asked at times, I see this with OpenAI frequently, they'll give me 2 replies and they'll ask me which one of these is correct. Not all the time, but maybe 1 out of every 20 prompts, they'll do that, right? And you see the same thing. Well, they'll show you 2 prompts. And again, that's where they're building up their reinforcement learning based on that. So, okay, sorry, I got distracted. Okay, let's watch this video. And again, you can do some prompts while I'm doing this. Okay, so again, this is LangChain. We haven't talked about LangChain, a company yet, but in the coming week, I don't think this week, I think next week, we'll be using them in our Python models. They are a library that lets us access the large language models and pull the results back from prompts and use that to send and do it. So I trust their work. I think they're an open source coding project there. Okay, just want to mention that.
I want to talk about these are reviews, my favorite new videos and blogs I've seen on this topic. First, let's just start with the current scaling paradigm that we've been in for a number of years, which is next word prediction. So Jason Wade is a great talk on this, and he kind of frames predict the next word or next token in the sentence. It learns a lot of things at once. It learns grammar, it learns world knowledge, sentiment, translation, spatial reasoning, math. So
So it's, I find it interesting to look at these examples. So again, they're talking about just grammar. And again, in my free time, I like to code or I like to banana. So both of those, one is, when would you use one or when would you use another there? And again, sentiment analysis, translation here, you see a lot of that in this sort of stuff.
Lots of papers and talks on it, but that just sets the stage. Now we scaled this over what we said, of course, to Jason also touches on this, and this is well covered in capital wallpaper in 2020. But with respect to the model size, data set size, and training compute, the overall capability of models trained just with this kind of simple objective has gotten better. Now, there's some interesting points here related to the concept of emergence. Certain capabilities appear to unlock at certain scales, like for example, GPT-2 and 3 before math, or greater math capability. But overall, you kind of think about the capability increasing in a relatively predictable fashion with respect to size, model, data set, and training compute. So that's kind of the paradigm we fit. Now, here's kind of the catch, and Jason kind of ends up nicely. Network prediction is kind of a system one thing. It's fast and intuitive. But some next words are really hard to predict. So, for example, a challenging math problem, a challenging reasoning problem. The problem is, these models use the same amount of compute to solve easy and hard problems. That's kind of the overall problem with this paradigm. Now, a workaround that we're all probably familiar with at this point is this notion of data hub prompting. This came out in 2022. Jason Williams' paper on it. Of course, you prompt element things up to step. But what's really happening here? So Nathan Lambert has a nice video on this, and I thought it was really interesting. You're kind of trying to enforce the system to think, which is conscious and ethical. So for example, if you do a math problem yourself, you perform a bunch of intermediate steps, and those are kind of stored in intermediate variables for yourself, which then you utilize to generate a final solution. And here,
so I don't know if what your social media or what your YouTube is here, but I strongly recommend, like, especially, I like this sites, sources, and that sort of stuff. And I think this video is really nice because we have links or we have other people we should be following. If you're not familiar with them, you should follow them on them also. So one thing to keep in mind is what is in your social media feed. And if one of my goals in this class is just to try to push your social media feed to include a fair amount of machine learning and AI stuff. So consider pushing that there. So, okay, sorry.
kind of forcing the model to produce those intermediate as tokens along its trajectory for the solution. So it's like, by going to things step by step, you're actually having it produce work in the form of tokens, and then the tokens are kind of storing the intermediate information that the model's using for the form of final answer. So it's kind of like a hack to force the model from system one thinking to system two thinking. So I kind of like the way that Jason lays that out and Nathan explains what happens when you actually do CFT. Now, this new scaling paradigm to 3D models is basically scaling reinforcement learning on chain thought. So what's actually happening here? There's a nice blog from AI, nice video from Nathan, but really the summary is that you have some training which contains explicitly correct answers. This is important, okay? Coding problems, math problems that are verifiably correct, okay? You have a model that can sometimes generate correct solutions, and you have a grader that can verify whether or not a model output is correct or not, okay? And if it's correct, you give the model a reward. Now, this is where the reinforcement learning comes in. You have some policy that will nudge weights so it's more likely to produce higher reward outputs. Now, what you do is we train this on this data set as many explicitly correct answers for every problem. You basically have the model produce a bunch of trajectories, and you grade them all, and you reward the correct ones. And over time in training, you use lots of forward passes, okay? But
one thing it's interesting is that how AI has enabled us to do more stuff, particularly with AI, and that sort of, I've been working on a project where, I'm asking the user a question and they're replying back. And I basically want a yes, no, or, is this good or bad sort of response back. But the user often says, yeah, that's what I think so. It's a conversational interface. But now I can use AI, I can feed that whole user response and ask a language model, is this basically a yes or a no, and have the AI come back yes, no. And again, that's what they're talking about here. There's a grader, and again, this is usually a large language model where we say, this is the correct answer, and this is what was given. And so again, when we are looking at this, this reply back, we ask how many cows does the farmer has, and the correct answer is 8 cows. But this is the phrase, this was the response back. It's a big, long 2 or 3 sentence response. But you can feed this to an AI with a prompt and say, does this phrase equivalent to the answer 8 cows? Is it giving me the correct answer? And the AI can reply that. So we now have this grader, which is key to this refinement learning, is an AI doing that. Now, it's not a person. So
the model to favor chain of thought or trajectory that was holding the correct answer. That's the overall intuition. I think more will come out on this, but this is kind of my distillation from reading the blog post and the nice work I made in Management to explain a little bit of detail. Here's a nice kind of schematic book. The training day, the policies, the weights, you have some verifiable reward, and you're basically running your model over the training data. You're multiple passive, you're rewarding the correct chain of thoughts that get you to correct answers that are verifiable with your grade. That's the big idea. Now, why is this exciting? Well, it represents a new scaling law. So some really nice videos from Noah Brown, who's explained on this. If you look at the recent results from 1 and now 3 just dropped right before the new year, they're obviously extremely strong. So this is exciting. Now, another way to think about this is, I really like this slide from David Gray from Nerds. Benchmarks are getting saturated more quickly. This is a cool visualization showing how long it takes for benchmarks to get saturated. It used to be in 2012, it would take like 8 years, right? Now it takes like 8 years for GPQA, which is a new benchmark made by David Gray, which was group QAs, question answers that are not easily Googled. And basically, we're seeing new data reasoning models are basically saturating on benchmarks very quickly. So it's exciting. We're early in the scaling curve. That's a big idea here. Now, here's what I think is really interesting. There's actually a lot of confusion about O1 models. Some people saying, oh, these actually are really bad. Okay. Now, Ben Hilak and Swift got a really nice post on latent space. And it really helps to clarify when you work with reasoning models, you should not think about them as chat models. And you shouldn't prompt them as such. There's this nice visualization of the anatomy of.
So this is why I was trying to bring up, at first I wasn't going to talk about reasoning models till later in this course, but then I was looking at this prompt stuff, and I know it's often when people aren't paying attention, they don't know when they're dealing with a reasoning model or a chat model, and they're prompting it the same. So that's one of the reasons why I pulled the whole reasoning model stuff into this unit here, because the way you prompt a chat model, something that's trained just to predict next word, is different than how you would prompt a reasoning model.
Where what you're doing is giving it an explicit goal. You don't tell how to write, you tell it what you want. You give it a return format, warnings, and it just dumps all your work. Now, a lot of people show that this type of prompting works really well with O1, right? So unlike chat models, you try to tell it how to think. You're a researcher, you're thinking step by step. With these models, you don't do that. You give it what you want, and you give it as much context as possible. Okay? So that's really the context on how to prompt these. Again, focus on what, not that. Don't tell us to do, particular style of reasoning. Just give it a look. That's the big thing here. Now, let me show you use it very quickly. First, there's a few models that will do the API O1 and many. One thing we'll know, the need not for system has to do is small things to note. Now, parameters. So with one, not only you can provide these values of reasoning effort low, medium, high, this just tunes the amount of reasoning the model will do, basically faster or slower responses, fewer and more tokens stored. So I'm gonna go now.
Okay, so I'm going to skip over some of this. This is, and again, we'll see this, but this is, we'll see this in our Python code. This is how we will use LangChain in our Python stuff to access the language models and pull things. So we'll talk about that, and I'll give you the code that'll do that. But I'm going to jump down to this use cases and skip over some of this. So where it was use cases 930.
So, so I think the data really work on this. So what we've heard and seen what it is, these models are very strong at one-shotting entire files or sets of files. So in the case there's workflows and tutorials on this, how to basically give O1 a overall problem, give the opportunity to produce or edit a large set of files, and they can do that often in one shot. So coding is obviously the smash use case of these models, and they're trained obviously on very hard coding problems. They perform very well at Sweden, which is a popular coding benchmark. So coding is obvious and a very interesting application area for these models. Now, another one is this notion of planning agents. And so in a lot of cases, we've seen agents or agentic workflows that use some.
So we haven't talked about agents yet. I think that's 2 weeks off, but we will be doing agents. And again, we're often looking at agents as things, well, one agent might do a particular task, and then you might have a set of agents, or you might have a series. So we will use agents where we will set up a set of prompts where we'll first send one prompt, we'll get the result back, we'll analyze that, and we'll send it off. And when we can actually use systems that have that built in, so you can define your agents and give them tasks, and they'll go out and do a set of things there. And we'll talk more about how they're getting better at integrating with lots of other tools. But that's when he's talking about this agents and stuff, what he's talking about. And we'll
kind of pre-planning step up front, which kind of lays out a set of follow-on steps that they execute by smaller LLMs or, by an overall workflow, okay? So there's a lot of those from Unified that actually showcases this using LangGraph. But I think this general point about using these for upfront planning workflows or agents is obviously a natural fit. Another interesting area is the next preview kind of laid out from what kind of LLMs are seen or interesting, and I think kind of reflection over source of information through meeting those documents is interesting. This user follow up with what's most important thing to pay attention to, pipeline meeting transcripts in and kind of pieces of rational things. So I think that's kind of a generally interesting area of these models is kind of deep reflection over some large set of context, meeting those documents, papers. Now, data, similarly, I've seen a lot of people report on utilizing these models for analyzing blood tests. Very good for medical diagnosis, for medical reasoning. Of course, people may not want to actually share private medical data with an API. Totally understandable, some people do. But anyway, I think that medical analysis, diagnostics, engineering, or other areas of data analysis are obviously very strong for these reasoning models. So another one is kind of research and report generation. So you see deep research from Google come out, which is interesting. I think doing deep research kind of with O1 as your own kind of workflow is obviously a very nice use case for O1. Then mentioned is a lot of those elements judge. And so basically.
So I haven't been using AI to do, the one thing I hate doing most is grading, and I haven't been using it to do grading yet. It's not integrated into our Brightspace system, so there's not easy way. But this semester is one of my goals is to figure out and to test out, because all I'm thinking, these models, I've been using it in some other places. I think some of these models, I'm not great at grading. It's a weakness I have. And so I think it could help me be better. And again, I think that's one place you want to look at AI is where's a weakness you have, and can the AI help you in that weakness, especially if it's a job that you have to do, or if there's some component of your job you don't like to do, can you have the AI do that? I mean, that's one of the goals of this, is that we want to eliminate some of the stuff we don't like to do in our job, our daily tasks. And then we can focus on stuff we like, we'd rather be doing. And so I haven't done that, but it is my goal this semester, is that by the end, I have tried this out. I'm not quite sure. One of the problems is that, like, I either need a system that can use the web browser to do the grading and know what to click on. And again, we're just beginning to see those. I haven't tried that out yet. Or again, I'm downloading a zip file. I have to unzip the zip file, and there's often zip files within that zip file for every student. And then I have to then put those all together into some like list of file. You know, there's a whole process that I would need to somehow automate, and it's not consistent on how it would be grading. So, but that's someplace I'm looking at. And that's what we're talking about LLMs as a judge.
People very strong that they so I think in any kind of workflow where you have an evaluation step, either it's online or within offline, these also be very strong. If I'm not making a note of cognitive layer of newsfeed, and this is similar to the reasoning point above, but I've actually seen a few specific examples of this.
So they're talking about using AI to generate news feeds or to generate marketing stuff. So my question is do you see AI generated content out there on your social media, and do you know? So, and what I have trouble parsing it and figuring out what it does. So for example, I posted a second article here, YouTube video here, which I think is 90% AI generated. I think there's a little bit of human involvement, but not that much. And again, this is one of these AI channels that they're getting lots of hits by being fast. Whenever there's new news, they're trying to be very fast. And they're trying to have some sort of heading, that's going to pull you in some sort of way, whether or not you call it, whatever you want to call this thing. So this is the AI revolution. I don't know.
New AI model, Ernie 4.5 and Ernie X1. And they went ahead and made them free on their Ernie.
Okay, so a couple things. To me, that voice is AI generated. And so that probably means the script was AI generated. So they're using AI to scan the news, pull the news articles out, and generate a script from the news article, feed it to a voice model, and read that. So I think that, to me, the whole voice and stuff is all AI generated, right? Listen to it again.
He bought a platform ahead of schedule. Seriously, free. This move has got the entire tech scene going wild with Baidu open.
Or they're using one of the chat models. I don't know if you've used any of these, where again you can feed it and it'll have this sort of it'll generate a conversation like that for you. Now the images, watch the images. I think most of the images are generated. I think my guess is that whoever creates this has a system. Whoever runs this channel has a system where they feed in a couple key videos or key points, and then the system generates a bunch and uses some of the feed and stuff. So maybe they search the internet and stuff like that, but
AI tools to everyone, not just major players. Now, Baidu is not new to the AI conversation. They were one of China's first big players to roll out a generative AI platform back in 2023. But
again, a lot of this seems to me to be, again, they show a lot of videos of websites and stuff like that, and sometimes they're not even that related to this. And then they have a fair amount of generated content. Let's see if I can hear. So this is obviously image generation from one of their, from one of the image generation models, or a video. I don't know if this is moving. Yeah, so that's video generation snippets. And again, so I don't know. seen, what's your thought? Of this sort of stuff? Do you see content like this, and how much of this is AI generated?
I'll usually one up on Instagram, I'm doing a video. Talking pretty long.
Right,
I'm doing the all slow motion or something, figure time is off.
right, okay, yeah. So, and then I don't do Instagram videos that much, so, but I do take, are those just, again, what are they, 60 to a couple minutes? Yeah, right, right, so that's a good place. So you see much AI generated content there? Right. That would be, yeah, it'd be interesting, the trade, yeah,
Heard like content that are really popular on Facebook.
okay,
Older generation can't really.
yeah. I'm on, well, I'm not on Facebook, but I'm an older generation, I have lots of friends on Facebook. I try not to go on it, but
I think the one that Carlos like Jesus.
yes, some of the political stuff on there is just crazy, so. Yeah, and I could see the kids stuff, because again, I remember Teletubbies, and is very formulaic, I don't know, what generation of kids' videos did you grow up in? You were not Teletubbies, obviously. Little bit, so Blues, I don't remember what were the, so again, they're very, so episode, or even, and again, you want to make them, those were I remember the 30-minute or 20-minute TV spots, but often now you want shorter clips that will stream on on a channel or something like that. So, okay, so again, this person is then talking about generating this sort of content.
Or to monitor, notifying trends on social media. I have a number of apps to similar things that I think is really nice use case, and I think you.
Okay, I'm gonna skip the rest of this and go down to the end here.
Description, reasonable scale using RL over thought. The reason that the chat box can think that system one, fast, intuitive reason.
Okay. So on we'll try out some of this stuff on Thursday in the learning activity. And I'll try to, I don't have the project posted up yet. I haven't updated the project for this year, but I'll try to post the project also. Okay. See you on Thursday.
Tom, I have a quick question.
Sure.
It's just regarding I got a job offer. I took an interview
Uh-huh.
before spring break, and I got an offer, and they were wondering if they could get in contact with you because I told them about